What if I told you there's a single number that basically runs the entire universe? I mean, a number that's woven so deeply into the fabric of reality that it has obsessed and honestly completely baffled the greatest minds in physics for over a century. Well, today we're diving into that mystery. We're going to try and unravel science's most enigmatic number.
And there it is, 137. Looks pretty simple, right? Almost random even. But this number, it holds a deep secret about the very blueprint of our existence, a secret that scientists are still struggling with today. So what on earth makes this number so special?
Look, you don't have to take my word for it. The legendary physicist Richard Feynman once called it one of the greatest damn mysteries of physics. He said, and this is a direct quote, that all good theoretical physicists put this number up on their wall and worry about it. I mean, think about that. Why would a simple number cause so much anxiety for some of the smartest people on the planet?
Right, so this obsession with 137, it's not a new thing at all. For over 100 years, it's captivated not just physicists, but thinkers from all kinds of different fields, each one trying to crack the code and figure out its ultimate meaning.
You know what's so wild is that this number seems to build a bridge between completely different worlds. On one hand, you've got physicists like Wolfgang Pauli, who was so consumed by it, he started working with the psychoanalyst Carl Jung to understand it. And in physics itself, it's the glue that connects three of the biggest ideas we've ever had: electromagnetism, relativity, and quantum theory. And then, just to make things weirder, it also pops up in ancient mysticism, like the Kabbalah. It's everywhere.
So let's get into the physics. What is this number really? Well, it's basically a shorthand for a concept that controls one of the most fundamental forces in the universe, the force that literally holds our world together. Okay, its official name is the fine structure constant, and it's usually written as the Greek letter alpha. All it is a number that tells us exactly how strong the electromagnetic force is, and that's the force that holds atoms together, it powers all of chemistry, it decides how light and matter interact. I mean, it's one of the four fundamental forces that literally build our reality, so kind of important. Now, here's what makes alpha so incredibly profound. It's a pure number. It doesn't have any units, like meters or kilograms or seconds attached to it. It just is. This means that any intelligent civilization anywhere in the cosmos, using whatever measurement system they came up with, would eventually discover the exact same number. It's a true universal constant.
Probably the best way to wrap your head around alpha is to think of it like a cosmic tuning knob. It's like a dimmer switch for the entire electromagnetic force. It's the dial that sets just how strongly an electron will grab or release a particle of light. The value of this constant is quite literally a fundamental setting for our reality.
But here's the catch. The value is approximately 1/137. As you can see from our most precise measurement ever, it's not a clean, simple integer. And that little decimal tail right there, that 0.035999, that's where the real scientific detective story begins.
For decades, physicists were just totally captivated by the idea that the number wasn't just close to 137. They wanted it to be exactly 137. I mean, a perfect, clean, whole number governing the universe, that just felt too beautiful, too elegant to not be true.
And the biggest champion of this whole idea was the famous astrophysicist Arthur Eddington. Back in 1929, he was absolutely convinced that the number was precisely 137 and that he could prove it using nothing but logic, pure deduction as he put it. It was this powerful, beautiful idea that the universe's deepest rules were based on simple integers.
But, science can be a cruel business. That dream of a perfect 137, it just didn't hold up. By the 1940s, experiments were already hinting that the number was a little bit off. And as our measurements got more and more precise over the years, the value just stubbornly refused to be a simple integer. It's a classic tale, really, a beautiful theory getting taken down by cold, hard facts.
Okay, so if it isn't a perfect 137, why does this specific, kind of messy value matter so much? Well, it turns out that our very existence hangs on it being almost exactly what it is.
And this brings us to this really mind-bending idea called the anthropic principle. See, in our universe, the value of alpha is dialed in just perfectly. Atoms are stable, but not so stable that chemistry can't happen. Stars can ignite and shine for billions of years, creating all the elements we need for life. But if you just tweaked that dial a little bit, the whole thing collapses. Make it a little stronger and stars would burn out in a flash. A little weaker and atoms couldn't even form in the first place. Our universe would be a dark, empty, sterile place.
So we've established that this number, the fine structure constant, is this fundamental setting for our universe, and it's perfectly fine-tuned for us to be here. But the story has one more absolutely mind-bending twist. What if this fundamental constant isn't actually constant at all?
Yeah, I mean, this is one of the most exciting questions in all of cosmology right now. For basically a century, we've just assumed that the laws of physics are the same everywhere, and for all time. But what if that's just wrong? How could we even begin to test an idea like that?
Well, the answer is to look back in time. And we can do that by looking at quasars, these incredibly bright objects at the very edge of the observable universe. The light from a quasar might take billions of years to get us. And as that light travels, it passes through ancient gas clouds. And the atoms in those clouds leave a fingerprint on the light. A fingerprint that tells us the value of the fine structure constant way back then.
And the results we're getting are tantalizing. Some studies, looking at this ancient light, have found hints that billions of years ago, the fine structure constant might have been just a tiny bit smaller. Now, to be clear, this is still a huge debate. Other studies have looked and found no change at all. But just the possibility, the very idea that a constant isn't constant, would force us to rethink everything we thought we knew about the universe. So this brings us right back to this central mystery. We know what this number is with just breathtaking precision, 81 parts per trillion. It's the strength of electromagnetism. We know how to measure it, we know our existence literally depends on it, but we have absolutely no clue why it has this specific value. No theory we have, not the standard model, not string theory, nothing can predict this number from scratch. It's just a number we have to measure and plug into our equations by hand.
And that leaves us with this incredible, almost haunting quote from Wolfgang Pauli, which just perfectly captures the deep frustration and fascination of 137. It is still one of the deepest, most fundamental unanswered questions in all of science. Why this number? The universe, it just isn't telling us. At least, not yet.